Hello and welcome to the first of a multi-part tutorial on our examination of raycasting. Raycasting traditionally is oftentimes used for weapons, particularly supersonic weapons, but it can be used for a lot of different things, including deciding whether a camera sees something or not. For what we're going to be doing today is we're going to be using it for pistols, and we'll culminate it using to create a zombie shooting range. Now, there are several parts of what we're going to be doing here. The first objective that's going to be important to us is understanding how raycasting works, how to call it out in code. The basic form is physics.raycast from a location in a direction and then storing what you hit. We'll create a 6-shooter that leaves bullet holes in the walls, and these bullet holes will eventually disappear. And then when we have mastered that, we'll eventually make a shooting range, kind of a training range that we can run through. Now, there are some things that we want to kind of review, though. We've already talked about this idea of Framemiss. That is an object travels, let's say over 7 frames from where we see here on frame 1 to frame 7, that there are, of course, 6 discrete steps between those. And that if during one of those steps, 2 colliders actually intersect, then Unity recognizes that there's been an intersection at that location and instigates the physics engine so that we see things bouncing off and falling. However, if that object actually is between where Unity is checking, then Unity never actually sees the collision, and it registers this as Framemiss. Now, we talked about this in the Tin Cup Alley project, and we looked at how to overcome that by changing how often it checked for collisions. But there are some other ways that are cheaper than that very expensive method that we used there. This is where raycasting becomes important. What happens is this is what Unity's API says it is, that it casts a ray from the point origin in the direction called direction of a length called max distance against all colliders in the scene. This is the basic idea. It takes an initial point, any location in space, that is an origin. This is a transformed opposition, a vector 3. It's a location. And then it casts a ray in a particular direction. So, for instance, vector 3.forward, or transform direction vector 3.forward. And it casts that ray over a certain distance, although this is an argument you can actually leave off if you need to. And what happens is if that ray strikes anything with a collider in the scene, then importantly for us, it can store the name of that object or that object in a particular type of variable called a raycast hit. Now, raycast hit is a type that stores all sorts of interesting things. It'll store everything from the direction of the normals of the surface that you hit, to the material of the surface that you hit, to the color of the material to the surface that you hit, all kinds of things. For us, all we're really interested in is making sure that the thing that we hit, we need to know whether it's the zombie. Or in our case, we're going to have targets that pop up that are little kids. You can't shoot the kids, of course. So we need to know kind of what it is that we're hitting. So the way that we'd be doing it is raycasting from the tip of a pistol, from the tip of a gun. And as we shoot out, if the ray in a single frame strikes something that is zombie, we can start to check to say, hey, if that is the zombie, then I want you to talk to zombie and do some damage. Now, of course, this isn't legitimate code, and we'll talk much more about how to kind of build this out officially, but I want you to kind of understand the general idea. All right, let's move over into Unity. On the forums, there are several files that you'll want to download. One is going to be called the Unity Raycasting Starter project. I'm working in Unity 2019.3. If you haven't upgraded to 2019.3, probably go ahead and do so. If you see any errors with the standard assets when you first start off, make sure you delete those offending scripts. It shouldn't take you too long. The second thing is there is a pistol .fbx that's included in the thread. So make sure you download that. Again, we want to do kind of the same things here. I'm going to make sure that there's no rig, there's no animation. And in the materials, I'm going to make sure and extract the materials. Let's make a new folder called textures. I'm going to extract the textures here, and I'm going to go ahead and extract the materials here as well so that I can adjust them in game. All right, so this is the same set that we were using for the rocket launcher. Basically, we've got a first-person controller in there. That first-person controller kind of does what we would expect. This is just the standard stuff. I'm going to grab this pistol and go ahead and drag it into the scene. I'm going to drag that as a child of the first-person character. Remember, that is the camera. And I'm going to go ahead and zero out its location. Now you can see that there's several things that are important about this. There's just a downloaded model. It's got problems. Number one, look where its axis is. Its axis is kind of down in a weird place, not at the end. Second is you can see that its positive Z is off to the side. So we're going to want to do some other adjustments to fix that. For now, though, what I'm going to do is just eyeball this in so that it's actually a reasonable size for my scene and placed in a reasonable place for my camera to see. So I'm looking at my game view down here. I'm looking at what's happening up here. Again, you want to get that in a reasonable position. Now the first person character is pretty tall, 6'7", 2 meters, right? Fairly tall character. But make sure that that gun doesn't get really, really huge. Now there's a bunch of other things that we can do with this. For instance, if we come into that pistol, the pistol has got all sorts of shaders on here that we can decide to come in and maybe make more shiny. If we're going to have this be a shiny pistol here, we'll do this just for fun with the woods as well. And I'm going to do this with all of these just real quick, just to make it feel a little bit more shiny, even though we probably generally should have taken care of this kind of thing in our modeling package or in Substance Painter. Okay, but in a pinch, this will work out fine. All right, so that should be looking a little bit more like I want it to do. I want a shiny 6-shooter. Okay, we could also go in and change the colors if you wanted, or things like that. What this should do, though, now is that because it's a child of the camera, when I press play to play the game, then as I'm running through the game, that gun follows me. Now I am hearing that blasted. I'm going to make sure and get rid of the head bob, and I'm going to make sure that the volume on this is 0 because I don't want to hear the footsteps. Okay, so now I'm ready to start to set up the basic raycasting here. Now, of course, I don't want to actually raycast out of the pistol because the pistol's axis is in the wrong place and it's facing the wrong direction. So in the same way that we did with our rocket launcher, what I'm going to do is make an empty game object, and I'm going to call this Raycast Origin. The name doesn't really matter. What I am interested in, though, is making sure that I'm on pivot and local so that I can see where it really is. I want to make sure that the forward, the positive Z, is pointing in the direction of the pistol. It doesn't have to be perfect where this is, but that's a reasonable place to put it. I also want to make sure that, just for simplicity's sake, I'm going to put it out at the end of the gun so that when I do raycast out of that, it doesn't actually hit the gun. Now the last thing I want to do is make sure, of course, that this Raycast Origin actually goes with the gun. So I'm going to make sure that the Raycast Origin is a child of the pistol. All right, so that's the basic setup that we've got going. Now, nothing visually is going to happen here that's of much use, but let's come in and start to look at what the API tells us about raycasting so that we can understand this a little bit better. So I just opened up the API. Let's look at Raycast. Specifically, what we're interested in is physics raycast because we want to collide against anything with a collider. As we look at the examples, so here's the description that we've already covered in the PowerPoint, but here's all the different arguments that are available for it. Now we don't need all of them, but what we do want is we definitely want an origin, a place to start, a direction, that the ray is going to cast. We don't need the distance or the layer mask, but what we are going to need is this tricky little raycast hit. That's going to be really useful for us. Okay, so there's a bunch of stuff here that we don't necessarily need, but what's happening is that every frame, okay, update, don't worry about all of this stuff, what it's doing is creating a variable called hit that is of type raycast hit. This is a bucket that we can store the things that we hit against. If we raycast against something, then here's all the specifications of the ray that it's casting out, then what it's doing is, notice it's storing what it hits inside of this bucket called hit. That's what this is, okay? It's storing it. And then what it's doing is it's drawing a ray that goes from the position that this script is attached to in the direction that the object is pointed, and transform direction is converting from local to global space. Multiplies that by the hit distance, and it makes it colored yellow. Now what this does is this essentially will draw a ray to help us know if it's actually ray casting. So to make things a little bit easier, what I'm going to do is I'm just going to take this, I'm going to copy it, and then I'll do a little bit of adjusting as we go. Okay, so I'm going to come back here and let's start to work with our script. So I'm going to make a ray casting pistol script, whatever you want to have for the name, and then go ahead and open that in Visual Studio. Sometimes copy and paste from the API is a great way to get started, even though you still have to understand what's happening there so that you know what things you can actually get rid of and what things you can't. Okay, so I'll come in here and I'm just going to paste that in. Now all of this stuff right here has to do with layer mask. This actually defines, you can allow the raycast to ignore certain layers that we don't need to worry about there. So I'm going to get rid of all of that because I'm not going to worry about it. Now, second of all, I'm going to come in here and I don't really need, I'm not using the layer mask anymore, and I don't even need a distance any longer. What I do need, though, is that I need to tell it that it's going to raycast from this position in its forward direction. That's why we need to make sure that the Z was facing forward, and I want it to store whatever you hit inside of that raycast hit. And then it's going to draw a ray that's going to be yellow if it's hitting something. If it's not hitting anything, then it's going to just draw a ray that's white. Okay, so let's go ahead and save this. With that saved, I'll come back over here, let it compile. If I don't have any errors, I'm going to use my raycast pistol script and I'm going to draw it on the raycast origin, okay, because I want it to originate from there, and that's what our script does. Now what will happen now is that as I press play, then what you'll see is it draws that yellow line, okay, and that yellow line is going out to until it hits an object. Now if you point straight up in the air, let's see if I can show you this. If I point straight up in the air, do you see how that goes white? Because it's not ray casting against anything. But as soon as I get down so that it's pointing at something, then it turns yellow. Okay. So what that means is that the ray casting is actually working. Now I can get a little bit more sophisticated with that. I don't really care about this white stuff, so I'm going to go ahead and get rid of that. I'm going to leave in this, but instead when I write this debug log, this is the same as saying print, I'm going to have it actually tell me what it is that it's hitting. So what I'll do is I'll come in here and say I've hit something and its name is, and then let's go ahead and add in whatever is in hit.collider.gameObject.name. So it'll tell me the name of of whatever is in the hit bucket. Okay, so I'll go ahead and save that. Let's come back over here and take a look. What we want to do specifically is watch for the log here. And when I press play, as long as I'm looking at something, then it'll show. So there's the floor, there's the steps, there's the pillar, there's the wall. You can see all the things that it's actually raycasting against. Okay, so one last thing is we start to look here. It's nice that it's raycasting. It's kind of tough that we can't see what it's doing. So I'm going to go out and let's just do a quick search for reticle. We don't want to spend too much time on this. I'm just going to kind of grab any reticle that's good. See, there's actually a pretty good one. I like that one. All right, so I'm going to grab that one. I'm going to save the image, and I'll just save mine on my desktop that I'm going to call reticle. And then back in Unity, I'll go ahead and import that image. So you can import it just by dragging it into the scene. That should work out. All right, now a few things about this. Right now, this is just an image. Since I'm going to use it for my UI, I'm going to convert the texture type into a sprite. This is a special type of image that works specially for UI. I'll go ahead and click on Apply. You can see that it changes just a little bit over here in the project. But now I can also come in and create a UI. Let's create a image in this case. And with that image, I'm going to rename it reticle. Reticle. And then I'm going to plug that reticle into the actual image, okay, so that it's actually sitting there. Now, of course, we can see a lot of things that are problematic here. First of all, I'm going to double check, hold Alt and Shift down, make sure that it's anchored in the center. I can see that it's too big. I'm going to come into the canvas and tell it that I don't want a constant pixel size. I want to scale with the screen size. And if we're using, let's do a 1920 by 1080, that should be fine. What that means is that this will always be the same size in our scene no matter what. Now the second thing that's kind of ugly about this is that it's opaque there, which I don't really want either. So I'm going to come and select my reticle again. And I'm going to make some adjustments over here. Number one, I'm going to tell it that I want to grab this information from the grayscale. I'm going to choose its alpha from the grayscale. What it will do then is, in this case, what it's done is everything that is black becomes transparent. Everything that's white remains opaque. Now, of course, this is kind of backwards for what we want. So I'm going to go ahead and open this up in Photoshop and reverse it and bring it back in. All right, so we're back. To make things a little bit easier, I've placed 3 images on the forums that will include the bullet hole, the bullet icon, and the reticle that actually already has the black and white set up correctly. On the reticle, all you have to do is just change this to grayscale and hit apply, make sure that it's a sprite, and you should be able to place it like we've placed it out into the scene. Make sure that once you've got it placed, that remember you can change things like the color if you want. You can make it more transparent by adjusting the alpha. What we want to do now is we want to start to make it so that when we press fire, that it goes ahead and actually creates a bullet hole. Now the way that I'm going to do this is I've created just a sphere. Here, I'll create a new one from scratch so that we can see it happen a little bit easier. I'm going to create a sphere. This sphere, I'm going to scale it down. Don't worry too much. I mean, you can build this to see how it works. But I'm just going to, we're never going to use this in the long run, but just kind of shorthand. So I'll just have that sphere there. Now the idea here is that what I want to have happen is that I'm raycasting out the front of that gun. When I press fire, I want it to instantiate this sphere, that bullet hole, on whatever it is I'm raycasting against. Now the way that I'll do this is I'm going to come into the raycasting script and I'm going to come into the area where it's actually raycasting. So right here it's raycasting. What I'll do is say if you raycast against something, and then if somebody uses input.get button down and we use fire 1, then what I want you to do is instantiate bullet hole. This is a variable that I've already created. I want you to instantiate bullet hole at wherever I am hitting. So I'm going to use hit.point. What that is that's literally the spot on the object that we're hitting, that exact point. So on hit.point, and let's just use quaternion.identity for now, although we're going to adjust that quite a bit later. Okay, so if I save that, I'm going to come back here, and then on my raycast origin, we should have a new bullet hole here, and I'm just going to grab that sphere and drag that sphere in. What I can do now is that as I start to play this, then you can see when I fire, it instantiates a bullet hole. Now there is a problem though. Let's say that I'm, firing along and I come up to here and I start to fire at that wall. Can you see how where I'm firing and where it actually instantiates the bullet hole don't match up? Now, this of course is a problem in how we've got this raycasting set up. Let's look at an illustration that helps to define this. What we've got is we've got a camera that we see the game in, and let's say that we see a wall like we just looked at there. We've created a UI that has a reticle in the middle of it, right in the middle. So the implication to the player is that where they are looking, where that reticle is, that's where we're actually impacting the wall. That's where the raycast is. However, what we've actually done is we have our pistol and we've got an origin point sitting right out in the end of the barrel, and it's raycasting forward from there, creating a raycast that doesn't at all match where the reticle indicates. So to fix this, all we've really got to do is we need to make sure that that source is actually down here where the camera's at. So we'd actually be raycasting out of the camera, not the pistol, but to the player, it would look like we were shooting from the pistol. So the easiest way to do this is I'm going to take this raycast origin, still got everything on it. I'm going to move it out of the pistol and instead make it a child of the camera. Now I can collapse the pistol so you can see the hierarchy there. So it's a child of the camera, and I'm going to make sure that its position is a 0, 0, 0, so that it's right exactly where the camera is at. Now I do want to show you that what's happening here is the first person controller actually has a collider that's sitting around here. I'm going to take that source and move it out here so it's outside of the collider so I don't end up hitting the collider itself. So I'm just going to grab it and slide it out a little bit like this. All right, so what should happen now is that when we get ready to hit play, then when we start firing, then that will actually fire where we think that should be firing at. So it instantiates that bullet hole right where we want it. Okay. All right, so there's several kind of interesting things about this. For instance, if I start hitting the fire a whole bunch of times, each of them are kind of stacking up against each other, which of course isn't what we want to have happen. And there's some other things that we'll need to adjust in a second. But try to get this far, and then we'll look at how to convert not using these spheres, but instead use a bullet hole decal.